Okay, welcome to today's webinar. My name is Matt Cederberg. I'm CEO of Coreform. I'll be presenting today's webinar along with Greg Vernon, Coreform Director of Engineering. And today we're talking about Coreform Cubit and how it can be used for automatic hex meshing for biological and material sciences. This is a 30-minute webinar. It's the first one we've done that's this short. Usually they're an hour, so we're excited to be more concise, but we're really excited about the technology we'll be sharing today. First of all, again, we'll just introduce Coreform Cubit, and then the majority of the webinar will be a live demo that Greg will be giving, showing the automatic Sculpt meshing functionality in Coreform Cubit. Throughout the webinar, feel free to ask questions and we'll type them back or ask them as appropriate. If you're not familiar with Coreform Cubit, it is one of the best meshing tools out there. It's used especially for advanced meshing for challenging simulations. There's a lot of CAD import and cleanup tools, industry-leading meshing capability, lots of control with Python and other scripting. We've been adding isogeometric analysis pre-processing capabilities to Cubit as well. And just as a review of some of the meshing technologies available in Coreform Cubit, of course, we have TUT meshing. We have semi-automated hex meshing, which is what Cubit is often used for to get very high quality meshes on objects, but requires some manual featuring and decomposition of the meshes of CAD objects to mesh them. Today, what we focused on is an automatic hex meshing capability that's available in Coreform Cubit. And Greg will go into the details as far as the suitability of this mesh for various applications or applications where it may not be best suited. And I should also just let you know that we have also recently developed automatic flex meshing capabilities in Coreform Cubit for isogeometric analysis. This is what we're very invested in at Coreform, is developing a new isogeometric analysis solver that can run simulations directly on CAD models by immersing them and fitting high quality, higher order smooth spline hex meshes to those models. And so if this is something that you are interested in, we'll have another webinar on this in a month. But today we'll be focused on the Sculpt automatic hex meshing functionality. And so with that, I'll turn the time over to Greg.
Thanks, Matt. So what I want to share with you today is, and hopefully people are seeing my Cubit screen. I'm going to share with you today kind of a workflow that I like to use when I'm using Sculpt to kind of build repeatability and kind of speed into my Sculpt workflows. Now,
Drake, before you jump in, I forgot to launch our poll to understand a little bit who's on the line. So let me just launch that. If you don't mind chiming in to help us understand why you attended the webinar today. So what type of engineering models do you want to mesh? Why did you attend? Is it mostly mechanical engineering parts that are traditionally manufactured or additively manufactured? Biomedical engineering, material science, or CFD? So we'll leave this on just for another minute or so, or another couple of seconds, actually. Okay. All right. So here are the results of the poll. Looks like mostly biomedical today, some traditionally manufactured parts, and you can see the others there, Greg. So hopefully that helps give a sense of who's here today.
Yeah, that does. Yeah, and so since we have so many folks on who have done traditional manufactured parts, maybe I'd like to start off with Sculpt in those areas of application. So I'd just like to show maybe an example geometry that's kind of a traditional manufactured part. So as you can see here, this mounting bracket that comes from a NIST data repository. You know, it features a lot of things we see in traditional manufacturing: chamfers, fillets, through holes, and it's not a lot of organic surfaces. In traditional hex meshing, we would defeature this geometry to remove small features that would make it difficult for hex meshing. Or we would use tetrahedral meshing. Both of those capabilities do exist in Cubit today, where you could do a traditional hex mesh workflow, or you could build a tetrahedral mesh on it. As far as a sculpt mesh, I'll just show an example of what a sculpt mesh result would look like for a part like this, just to help contrast it. So let me open up one of these results here. So one of the things we can see with traditional geometries is that, and this is a very coarse mesh that I just produced just to help us kind of see this a bit more clearly. Sculpt, what it does is it immerses the entire geometry in a bounding box, and then on the interface of the geometry, it kind of sculpts, like a sculptor, the hexahedral elements to the surfaces. But what that does mean is that sharp edges tend to not be very well captured with Sculpt, and so you kind of get like this rounding effect. Additionally, some features, if we were to refine this, we'd see some of those oscillations would go away. But it is kind of susceptible to some numerical precision issues just with CAD in general. But then the second aspect is that if we were to do a cut through the middle, from a fine element standpoint, one of the things we'll see is that the bounding box produces high quality elements on the interior and tends to have lower quality elements near the exterior or near the surfaces. And so oftentimes in nonlinear analyses, we actually want the highest quality elements at the boundary as opposed to on the interior, since the boundary is where things like contact and the largest deformations exist. So for traditional manufactured geometries, Sculpt oftentimes isn't a great solution for those kinds of models compared to, say, tetrahedral meshing, or what Coreform is producing is the Flex IGA approach, which is able to then recover high performance nonlinear analyses. So I just wanted to demonstrate that, or demonstrate one of the side effects maybe of Sculpt for traditional manufactured parts. But where Sculpt is really good at is if we look at, say, something that comes from maybe the biomedical regime of, say, like looking at a brain model that comes from a CT or an MRI scan. So here I'm going to have one of the things that Cubit can do is it can actually load up STL files. And so I'm just going to start off with this, just a simple brainstem model. So we have just a small model to work with here. And so, one of the things we can make out here is that there really are no sharp edges in organic or biomedical geometries that come from like organic living tissues. And so not having sharp fits to sharp edges is not as big of an issue here. Now, as far as my workflow goes, what I like to do is, I like to use the GUI just to kind of do some just general setup, but then I like to work kind of inside of a text editor and command line. So typically what I'll do is I'll start with my geometry and I'll go to the Sculpt GUI tools. So to do that, I go into my mesh mode in my command panel. I then choose by volumes. And then there's, of the different actions, there's one that looks like a parallel computer. And that's where we can then enter into Sculpt. And so from here, what I can start to do is I can kind of do some previewing of maybe what kind of cell size do I want to have that gives me maybe a certain amount of elements here. So you can see as I change maybe my sizing, it's giving me an approximation of how many, this is actually how many total cells would be in the background grid. And this can give me a good starting spot. And I can maybe preview this mesh. Should work here. I can preview my background grid on my model. And so I can kind of get an idea for how big or coarse those elements might be. There are some settings that can be defined inside the GUI. One of the things you might notice is that just Sculpt has so many different options that you end up having to scroll a bit to see all the different settings. And especially on small screens, like on a laptop, that can be a bit of a pain. So we actually have added an option. If you go to Tools Options, there's a, in the layout feature, I think it's layout, it may actually be, let me just see real quick where is that. Oh yeah, the on the command panels to use the breadcrumb trail to save some space. And that just puts then Sculpt in its own whole setting. But so again, what I like to do is I like to, when I come over to the actual setting up of my mesh, I like to not run Sculpt from Cubit. Instead, I like to have it create some files for me. So I might call this was the Brainstem. So I'm going to name my files with Brainstem. And what this will do is it'll write out STL files and needed prep files, as well as this input file that I can then edit in a text editor. And so that now if I just go and open that geometry or that, that directory that I wrote this out to, so you can see I've now got an STL file, I've got my input file, and then even a Windows batch script, and then a diatom, which is kind of an assembly of STLs. So if I had loaded in an entire brain with all the different kind of sub-organs, then this diatom would tell them how they're stitched together. So then once I've got my input file, you can see here there's text that kind of defines maybe what the different options are going to be. And I'm actually going to move over to a different text editor here now for a little bit. That if you want to run Sculpt, it is located in the same directory as your Cubit installation. So it's going to be inside of your, if you're on Windows, inside of C program files. And inside of the bin directory, there's a Sculpt executable. And so from a command line, that's the Sculpt that you would want to run. I've got this on my Linux subsystem here, and I've got Sculpt added to my bash profile. And then for options that I can use to fill in into my input file, if I just run Sculpt with the -H option, it'll then print out a listing of the different options I can use with Sculpt. And so I have to kind of start at the top and see if there's anything that I would want to have. So sometimes the thing I often like to do is that Cubit might by default specify the number of elements in X, Y, and Z. And I may want to switch that to just a uniform cell size. And so if I can find here that there's a cell size option that then takes an argument. So I can replace these lines with a single line that says cell size. And then back in Cubit, under my sizing, I can maybe find, an approximate cell size to give me a reasonable amount of elements here. So maybe if I go with a cell size of 1, that's 400 or 500,000 elements. And then it also has this bounding box. Now, Cubit does have some abilities for adaptive meshing. It does a form of mesh of adaptivity that's a conforming mesh. So it's not a true octree, but it does refine and then stitch the nodes back together to have a truly conforming mesh. And if you want to know, then say I want to do some adaptivity here, but I don't know what my options are, I can then run Sculpt with the -H flag, but then also I can pass in the specific option I care about. So in this case, adapt type. And now it'll give me help on that specific option. And so you can see now it's telling me that I can pass it in one of these types of arguments. And so maybe what I want to do is maybe I want to use like a volume fraction difference kind of method, where you can see here what it's going to do is it's going to compare like subdivisions of each background element to decide whether or not it should be divided. So I might then add this. Now, in the sculpt input, the $ symbol is a comment. So I oftentimes again like to mention that maybe this is going to be, my personal settings that maybe I'm testing out. I might try adapt type and then =6 for that. As you can see here again, they have these integers for what you can pass in. And maybe 6 isn't supported. So maybe I'll actually do 4 instead. I can look again at the different options that I had. I can have maybe a maximum amount of levels. So maybe I want to terminate this at maybe 1 or 2 levels just to demonstrate. So we'll go adapt levels =1. So there's other options I could set, but just for the sake of time, I'm just going to then show kind of how I would then execute this. So I'm in my directory here that I'm running. I can say that I want the option of I, which again, I tells Sculpt that I'm going to pass it an input file. So the sculpt brain.i. And I can tell it how many cores, so I want to run sculpt brain.i. I can tell how many cores I want to run on. So I want to run on 6 cores. I have an 8-core machine here, so I'm not going to try to run all of the cores. That's all I have to do. I can just hit run. And then Sculpt will then run through and then process the geometry. Now I don't have time today to run through or to let this finish, but I'll let it run in the background, and maybe if we have time at the end, I can share that. I do want to show what the diatom file for the entire, I have an entire brain assembly here, which if I load the rest of these geometries in, you can see. And so while those are loading, I'll show what the diatom file that I mentioned looks like.
So Greg, we've got a question
Yes.
about why you're spending as much time in editing code instead of in the GUI.
Yeah. So the reason for that is that not every option that's available in Sculpt is available in the GUI. And also the documentation is also not in the GUI as well. And so sometimes I'm kind of wondering what options there are. We do have in our reference manual, under the meshing operations section, and then meshing schemes, we do have some description here on Sculpt. You'll find it by search. That kind of walks through some of the different options in the in a picture form. But I oftentimes find that I just am much more efficient and effective if I'm working inside of a text editor, as well as that then once I've got these settings set, these are now, I can save this. I can save this with my project files. These Sculpt settings are not saved if I save my cub file. It's just the way that that Sculpt works. It's a separate executable actually from Cubit. And so if I've done things in Cubit and then I close things and come back a week later, I've now forgotten all the things that I'd set. And so really the source of truth to me is the actual input file. And then I'm just working in the command line with getting the different options for what I can use to run. And I'll then do tweaks. So I'll tweak a few things here. So I might change from adaptive levels 1 to 2, and I'll rerun Sculpt. And I just find it's so much quicker to do that if I'm running from inside of a text file.
So if someone's not comfortable with text files, are they still able to use Sculpt just out of the GUI?
Yes, they are still able to use Sculpt right out of the GUI. So instead of having turned on the do not run Sculpt option, you could just run it straight from here and then click mesh after you've set some settings that you'd want to have. Now, right now, as a developer at Coreform as well, I'm working through a bug with one of the latest development channels of Windows 11. So I'm on a beta version for Windows 11, and there's some future things that we have to figure out. So I actually can't today run Sculpt from my Windows box, just due to the latest betas from Microsoft. So I'm not going to be able to show you that today. But it is possible all from inside the GUI. Now, another thing to do is that when Sculpt runs, it runs on individual cores. So in this case, I ran on six processors. And so the output that you might get if you run an analysis. So here I ran Sculpt on a heart model, and Sculpt by default writes out an Exodus mesh format. Exodus is kind of the native format for Qubit. And it's an open source format developed by San Diego National Labs. But it's still in its decomposed form. So so 8 processors, and then this is process 0, process 1, all the way up through 7. And in ParaView, if we wanted to open those models, we could. So let me open up these models in their decomposed forms. And ParaView, for instance, is smart enough to recombine those separate processes. But they actually exist. I can open up each one separately here. Maybe ParaView may be too smart for me here to. I think I can color. Yep. So I can color by the processors. So what you might want to do though is you might want to have this back into a unified single mesh file as opposed to broken out. And if you want to do that, there's another executable that is shipped with Qubit. If you run Sculpt from inside of the GUI with the combined parallel files option on, then it automatically is going to run this executable. The executable is called EPU, which stands for E Pluribus Unum, which is the motto of the United States, which stands for out of many one. And so it's kind of a pun that says I'm going to, from many mesh files, I'm going to create one. So if I want to do that with, say, this heart model here, I can simply run EPU with an auto flag and then feed it any one of these broken out files. And then EPU will automatically determine what the other files were, and then stitch them together into this single .e file. And then that .e file I could then reload into Qubit if I wanted and look at my mesh. But I oftentimes will just load it up into ParaView, especially because I oftentimes will be running Sculpt, to create meshes that are, 20 million, 30 million elements. I might be running on a remote server. And so I maybe don't want to actually download all the files to my local computer. I want to see them. And so ParaView is a really efficient way to visualize and all that data from the mesh. Now, the last thing I wanted to point out is that this workflow is actually already documented for folks on our Qubit forums. So if you go to our forum at forum.coreform.com, if you go to search, if you search Sculpt, the top result should be a Sculpt workflow suggestion, where I've broken down this example, and you can download the files for the brain if you'd like, for the assembly. And you guys should work through this and do all the steps I've talked about today of preparing those text files for input, and then how to run Sculpt from the command line, and then how to stitch everything back together and then reload it into Qubit. So we didn't have time to go through all of these steps today and actually see this fully meshed brain just due to the time limitations of the webinar. But I encourage you that if this is of interest to you, I do encourage you to go to a forum and walk through this example, and then ask any questions you might have in replies. So that's about all the time I've got for today. So Matt, do you want to switch over to questions and answers?
Yeah, we've got a few questions. Thanks, Greg. And first of all, again, Craig, thank you so much for preparing this. Sculpt is a really powerful tool. It can go really deep, but also provides that push button immediate automatic hex mesh. So thank you for showing all of that.
Mhm.
Okay, a few questions from Hom. Are the sharp edges still a problem for sculpting, even if they are not in the outer surface? For example, what if there's a cube embedded in a sphere?
Yeah, so even in those cases, I mean, there are some settings you can choose or select inside of Cubit. I'd recommend looking at the pillowing options inside of Cubit or inside of Sculpt. But yeah, just sharp edges in general are challenging for Sculpt if they're not axes aligned. If your cube happens to be axis aligned with your background Cartesian grid, then you may get good capturing of those sharp edges. But in general, it's still an issue.
Thank you. Here's another question. If you're using Windows, do you just open a command window from the folder with sculpt.exe and use a similar process for running Sculpt?
Yes, yep, you could do that. So I've got Windows Terminal here, and so it opens up maybe a PowerShell, but I could easily open up a command prompt. And so I'm just going to navigate to, I've got a Cubit temp here. This is going to be dir. And so if I wanted to run Sculpt from this directory, I think I've got a .i file here. So I'll run this .i. I would just run C program files, Coreform Cubit, bin Sculpt, and then this -i Sculpt should be a .i file here and J4. Now, again, there's an issue with the latest Windows 11 beta channel that I'm working through just to capture what changes are coming down from Microsoft. So again, I can't today run on Windows, but as long as you're on just the standard non-developer insider channels, this should work for you. But yeah, that's exactly how you would run from Windows.
Great, thanks. So Greg, the full brain model, is that a conforming mesh that you have with multiple parts?
The resulting mesh that comes out, I don't believe the resulting mesh is conforming, just based on how I set up my script to run. That I use different sizes for the different regions because the individual organs themselves are not themselves connected. If we look at this at the input STL file, you can see even here there are separate volumes. And so these then get meshed individually. And so everything that's inside of the purple itself will be a conforming mesh, but it will not conform to the green or to the yellow regions.
So basically everything that's in its own bounding box is conformal inside of that, but not to other
Correct.
Yep. Objects. Okay, great. We've got a bunch of other questions. Is it possible to mix Sculpt with other meshing techniques?
It is possible. However, maybe not in the way that you might expect. And so what I mean by that is if you had an assembly that maybe had a bunch of parts that were traditional manufactured parts, and you'd done traditional hex meshing approaches, and then maybe you had like a topology optimized bracket, you could run Sculpt on that bracket by itself, and then re-import the mesh into Cubit, and it would live inside of your model just like all the other meshes that you'd produced had. And so in that way you can mix it. What you can't necessarily do is you can't take a challenging to mesh part like this, like the NIST part I showed earlier, and mesh 99% of it with a traditional hex meshing approach, and then build Sculpt on like a small portion of it and have it conform. That will not work. So it's really volume by volume. You can choose to have Sculpt or not have Sculpt.
And if you have some volume Sculpt, can those conform to other volumes mesh traditionally?
If the yeah, so not if they're meshed traditionally, I don't believe.
Okay.
There are a lot of different options in Cubit or in Sculpt, and so it may honestly it may be possible, and I just may never have had a situation where I've needed to do that.
Okay. Is there a way to confirm the quality of the mesh, like for instance, to see if all the elements of a Jacobian greater than 0?
Yeah, so Sculpt, when it runs, it does a couple things. If I had let this complete, which I guess I did, as Sculpt is running, it does a post-processing stage where it's smoothing out the elements, and it will tell you some information about like what the minimum scale Jacobian is. And so a scale Jacobian of less than 0 is inverted. And so as you can see here, as it's going through and then improving the mesh quality, my eventual minimum scale Jacobian is about 0.11. And so now I've got no inverted elements. So that's one way that Sculpt will tell you just right inside of it. Otherwise, inside of Cubit, once you've loaded in a mesh, let's turn off breadcrumbs here for a little bit. We do have for the hex, if you go into the hex entities, you can then request quality metrics on, say, all of the hexes and get out, say, scale Jacobian or shape, or whatever you want. And then you could make a plot of those elements there and some printouts. But again, if you're running from the command line, then Sculpt is just telling you what those worst quality elements are.
Great. Thanks. Okay, just a few more questions. How would Sculpt handle tubular-like structures with branches like branching blood vessels?
Yeah. So again, being organic, Sculpt tends to do a better. I mean, the hexes that get produced tend to be of what we might consider a higher quality than what we might get on a traditional manufactured part. What I would recommend is that when you have regions that are where you have maybe, I can imagine like an artery, and like the difference in diameter from an artery down to like a capillary is quite large. And so that may be somewhere where you want to use additivity and be quite aggressive with the additivity as well. But if you do have cases where you have those large differences, it may happen or may occur that the Sculpt might miss those small features that branch off. And so if that's the case, then I would recommend using a denser or a finer initial mesh. But that is a good general application for Sculpt, or these biological or organic shapes.
Great. Okay, for the NIST part you showed earlier, how would you improve the sharp edges? Is there a more preferred technique for sharp edges besides Sculpt, or would you just improve the mesh size?
Yeah, so with Sculpt, there's some beta functionalities to try to capture sharp edges, but those are honestly still deep inside of beta. And so you might, if you look at the capture options, that's what you would want to look at, is for capturing the sharp edges. But Sculpt just in general can't process those sharp edges. It's just not the best tool for that kind of job. And so honestly, what I would look at doing is either doing tetrahedral meshing or traditional hex mesh approaches for those problems.
Okay. Let's see, we'll just get a few, there's a lot of questions coming. Let's ask a few more. And then if we don't get to your question, please go to the Coreform form that Greg mentioned, and we'd love to continue the conversation there. Okay, is there, can you define side sets with Sculpt?
You can. So there's an option, and I'll show this inside of Cubit here, that you can create your side sets on a geometry. And then inside of Sculpt, there's an option. And of course, it's going to try to size everything here for me. So let's give it a second here to respond. You can then define side sets based on geometric surfaces or side sets or things that you had previously set. And so then those will, as well as they can, if that surface gets represented, it'll add the side sets back into your model. And so we can even look at, if we look at the documentation for Sculpt, we can probably find exactly what those commands are. So anyways.
Okay, thanks. So just one more question about the sharp edges with Sculpt. What happens if Sculpt can't process those? Will it terminate or fill in elements, or what happens with sharp edges?
Nope, it just kind of rounds them off. It doesn't really see them any differently than anything else. It just can't, you know, when you've got sharp edges that, especially when they don't align with the background grid, Sculpt just can't bend the elements kind of that much to capture them, is really what the issue is. So it just builds a hex mesh that just doesn't have a great capturing of the sharp edges. If you do a finer mesh, you tend to get a little bit, you know, sharper edges on it. But again, it's just not the best tool for sharp edges.
Okay, we'll do two more questions and then hopefully we can continue the rest of the conversation in the forum. Is it possible to define refinement boxes?
I don't think it's possible to define refinement boxes. Although, you know, that is something that we've heard a couple people ask for. So we may have to look into that, but I don't believe there is functionality for refinement boxes.
Okay, and the last question from Patrick, thanks for the great demo. Extracting surfaces from something like MRI or CT scans can sometimes lead to some nasty surface geometries like small features or sharp edges. Is it possible to pre-process these surfaces in Cubit before passing them into Sculpt, or would you do that in an external tool first?
Yeah, I would do that in an external tool first. Cubit is really a meshing and like a fine element meshing tool, and kind of the stuff of extracting surfaces and smoothing them and healing STL files. Those are things that aren't in Cubit's wheelhouse. And so I do recommend using tools like MeshLab, Mesh Mixer. If you've got tools from Autodesk, I think they've got like an AM preprocessor. Materialize Magics has a good healing tool in their preprocessor. There's also like Aviso and Volume Graphics, and I would use one of those tools to prepare the input geometry. And once you've got that, then come into Cubit.
Great, thanks again for the excellent demo. Would you mind just pulling up the form one more time so that the questions we didn't get to, if we weren't able to answer your question, please ask it here on the Coreform form, and we'd be happy to continue the conversation there.
Yep. So it's just forum.coreform.com, and you can sign up, and then you can create a new topic inside of our Coreform Cubit if you'd like.
Okay. Great. Well, thanks again, everyone, for attending, and we'll see you in another webinar. Take care.